We could always detect movement or motion, smoke, heat, flame. We could have pressure sensors. We could be monitoring wear on equipment. And then, we all got amp gauges and other different sorts of monitors on electrical systems. But typically what we're going to be doing is measuring temperatures on bearings, monitoring, again, belt alignment, belt speeds, checking to see if the belt is slipping. Maybe have some choke detectors to see if a spout is plugged up. And the importance of that, again, is to detect a choke and a spout before maybe we take a leg down. And then we can also sense levels, grain bin levels, product levels, that sort of thing. All sorts of different equipment. Lots of it was on display out there. I really wasn't going to get into all the different types of equipment or the vendors that are in it. If we look at, this is 4B's, where they recommend putting these sensors. They would typically have bearing sensors on the head and the tail bearings. Typically, you would put a speed sensor down at the bottom on the boot. You could have plug choke switches on the throat. And then also you would have the alignment. And this is to me, one of the more important things is where do you put these alignment sensors? They'll show one up high where you could catch whether or not the head bearing slides or the tail bearing or the pulley. If the pulley slides to one side, you can catch the pulley. Then you usually want to catch the belt in one or two places. Now, me as a safety guy, I totally recognize that these elevators that were built 20, 30, 40 years ago, they're not straight anymore. So my theory always is, too, we need to find out where those curvatures are in our old legs, and we should put alignment sensors in where we know the belt is going to hit first. Because, some of those things are not plumb anymore. Something to think about. Now, when this standard was written, really before anybody had enclosed horizontal belts. So we really have the exact same sensing capabilities for these are basically horizontal bucket elevator legs. In the grand scheme of things. So you could, again, sense temperature on your bearings, head and tail. You could sense alignment, both sides of the horizontal belts. And you could have a slippage detector also on a horizontal belt. The trends in all of this equipment is really leading, of course, towards automation, remote monitoring. The old system sounded a buzzer. Now, again, we could be watching in real time, be viewing these temperatures. We could look at the speeds of this equipment without actually being next to the equipment. Cloud-based technology, wireless sensors now. And again, this data management. Before, we never captured or could collect this information. It was just an analog reading. It would show instantaneously, and then it'd be gone. And now we have a way of, capturing that and tracking that if we need to do that. Adjustable depth bearing sensors, different kinds of thermocouple technology, magnetic mounts. I'm not sure how many of you have used the magnetic speed sensors. It just makes installation so much easier. And now, again, how do we test this stuff? Some of the equipment manufacturers now are coming out with ways of testing their bearing sensors, testing speed sensors. Again, that didn't exist. That wasn't even possible in the past with some sort of definite machine or definite tool. We would all have different tricks or methods on how maybe we could test this equipment. So that's just now evolving, and that's a trend that we're seeing. And then predictive maintenance. Again, trends, here's just some examples. we could get colorful graphs and charts to show trend lines on maybe how a bearing is operating this month versus how it was last month. I believe that's a picture of a test device for a bearing monitor. Cloud. We've been doing a whole lot of this at our company, upgrading all of the hazard monitoring system to where, I could just, have an app on my phone and, I could look at the bearing temperature of, every leg in our system that has monitoring. I get an email every time an alert goes off in the system for whichever type of alert we have. We've got that captured in reports. And, we sit as a management team and discuss, why is this leg continually, or periodically, sending out alerts on temperature? What, is it an alignment issue? Do we have a bearing starting to go bad? But that kind of capability we have. Again, I could get it for all the facilities. I could get it just for mine. I could get it just for one leg. That's what's up and coming, and that's the new trend. And it's not real difficult to retrofit or to upgrade those old systems to this. So what are the advantages of going to this cloud-based system, with that reporting? Again, real-time monitoring. Again, we can monitor it from any location. We get those logs so we could see the history. Remote alarm notifications. Again, it used to be you had to be within earshot of wherever that buzzer was. Now, I could be in my pickup truck and get an alarm, on my phone. I could be, again, I might get them on vacation. I get them at home when second shift or third shift is running. It's those remote notifications. We get the data sharing and reports, and then we get system diagnostics. Again, we have a person that specializes in this on staff, and he could diagnose most of our systems now remotely, and get the parts on the way, get the items fixed, and that makes a big difference. There can be a security issue anytime you go wireless or anytime you put your data out there. Again, in the ag business, not all of our people are that tech savvy. That could be an issue. An initial cost really isn't that high. To me, that just upgrading the new systems is where we're all going. We're all going to eventually get there. Just how quick. This is where I really cut out of the presentation is the case study that Jim had prepared. But some of the basic things, again, when you're looking at designing a system, it's just assessing that need. Look at the requirements from a compliance standpoint. I just showed you all that OSHA requires. That's really all that they define. If we dig into NFPA 61, they'll have suggestions on additional monitoring places. What do we currently have? What risks do we feel we have now? Again, we've just realized that our legs are 6 inches out of plumb. That might be a new risk where we got to now monitor this new hazard. Maybe my insurance company or a third party says that I need to start monitoring something different. What can we afford? What's my budget? And then if I don't do anything, what's the downfall of that is always something that people look at. We look at compatibility. Do I need it to match something I already have? What type of equipment am I using, and what am I trying to cover? Who's going to be operating? And again, if we put in, I could tell you that there's many of our facilities that could not maintain this equipment. If we didn't have the outside resources, didn't have a corporate oversight, I would go in 3 years from now, the system just wouldn't be operating. Or they'd snip a wire because they didn't know how to, address an alarm issue. So you got to know, again, who's going to be operating the equipment. And then do you want the data? Do you want to collect the data? Do you want all the alarms? Those are just decisions to make. Availability, there is all sorts of slides in here about vendors and equipment, how to select a vendor. We got great vendors in this industry, all sorts of different models and styles. I could say pick someone you like using. You're going to be calling them a lot. This system or these systems require maintenance. They require a lot of TLC. They require spare parts. You need to have availability to those parts, and you need technical support. This stuff never breaks at 8 o'clock in the morning. Never does. It always is off shift, always on a Friday night, just the way it works. Now, after you install this new equipment, you now need to also integrate it into your safety program. Job hazard analysis. There's going to be new controls and new work procedures. And that really comes into this next one too. What are you going to do when the system quits working? So now all of a sudden you got this hazard monitoring system and the speed sensing equipment's not working. Can I operate? Do I have to shut down? How long is it going to be till I get fixed? Are there some workaround procedures that I could do to allow me to keep operating? You better have those defined and build that in, again, into your standard operating procedures, into your safety procedures. Training on how to use the system, training on how to recognize the alarms. Again, what do I do? When do I ignore an alarm versus when do I shut my system down? All that, has to be developed. And if you don't, they're just going to ignore the alarms. They're going to duct tape over alarms. They're going to cut wires. That's the way it works, unfortunately. And then you got to use the data. Again, you've got to look at the trends, and you should be able to spot bearings that are going out prior to allowing them to actually fail, because you should see that creep in temperature. The basic technology hasn't changed. However, what we could do with that thermocouple, what we could do with that signal, that's really where the changes in this industry has progressed. Again, with the remote notification, with the data collection. We got great vendors to choose from. Again, partner with one. The trends are going towards data collection, again, remote system, wireless, and cloud technologies, and then the integrated testing. I will tell you that OSHA is going to come in and say, how are you test, or if you have a catastrophe, they're going to say, how did you test your monitoring system? How do you know that it was working? Can you prove that? What frequency? Do you match what the manufacturer suggests? A lot of the manufacturers, it's just very generic on what they say. But I know we have a written procedure on how to test a bearing sensor, how to test a speed sensor based off what kind. And we have a defined frequency so that we could have that documented. Goals and objectives, what are you trying to accomplish? And then the selection criteria. He's got a chart here, which type of sensor typically costs more. You could look at that in the notes. Again, this is pretty well the closing, but training, the people have got to know how to use this stuff, how to maintain it, and what to do with those alarms. Build it into the safety program, and then manage that data. And you will have, with this new technology, you will gain in operational efficiency. You will gain in maintenance performance. You're going to make your people go out and look at that equipment. You're going to make them service that equipment. And again, visual checks is just crucial on this. And most importantly, you will, with this technology, improve the safety of your facilities. And that's it. We're going to have a couple people up here that install this equipment regularly and know hazard monitoring inside and out. I know it from the safety standpoint. These two individuals deal with installing and purchasing and utilizing this equipment more than what I would.
Thanks, Brian. Brian is also going to be part of our panel, so he's going to have a seat. Joining us as well today is going to be Jake Lang. Jake is also with Bartlett Grain, and he is their project manager. As well, Mike Anderson, who's from Schooler Company. He's an operations manager. So these three guys have a ton of knowledge, a ton of background in hazard monitoring. And so what we're going to do is we're going to open it up. If any of you have questions, please just raise your hands. Now's the time these guys can certainly answer any kind of questions that you might have. And I've got a couple here that I kind of put together while they were talking. But I know one of the big things you talked about, Brian, was the cost. What's it cost to get these put in? So pick just a general system and just kind of give us a good ballpark idea. What are we looking at as far as cost to install a typical hazard monitoring system?
Basically, if you start with just a basic leg setup, which would be your speed and your thermocouplers on all 4 bearings, and then 4 sensors for your rubs, you're looking at about a $2,000 investment on equipment. It will vary depending on the system of what your install costs will be, due to the different types of wires and conduit runs that you'd have to run to each system. When you build upon that one system, it gets cheaper per piece of equipment that you add to it, up to a certain amount of devices. So it basically goes up from there.
Anybody else?
A rule of thumb I've always used is just $1,000 a point. It usually gets you pretty close. So every rub block, Tom says he can't hear me. You never complained about not being able to hear me before, Tom. About $1,000 a point is just a ballpark that I'll use when I'm estimating. So every rub block, every bearing sensor, every speeds, by the time you put in wire and labor and all that, it's somewhere in the $1,000 to $1,200, $1,500 range. So.
Okay, so it's a piece of equipment, and we all understand what equipment does. Equipment fails, and we have problems. We have a lot of false alarms with hazard monitoring. How do you guys deal with your systems when you have false alarms?
There's no such thing. In my opinion, there's no such thing as a false alarm. You get an alarm for a reason. You need to find out what that reason is. If the system's giving you an alarm and for no reason, then there's something wrong with the system. So and if you're getting an alarm periodically, you need to go and check that rub block, you need to check the bearing, you need to check the slowdown and find out what's happening, because I've seen it way too often where a belt just touches and touches and touches, rubs a groove in the sensor, and next thing you know, it's not touching anything. So that is probably the most dangerous situation. So.
Yeah, I would completely agree with that. There's something going on. It's talking to you. It's telling you that something in your system, whether it be the wiring is messed up, to where it's not communicating correctly at all, or you've got some outside interference. He was talking about the radio miking up earlier and messing with the signals on a bulk scale. Same thing with some of these systems. They're very sensitive to outside communications, radios, wiring. Need to make sure that they're installed correctly and that the proper grounding is in place so that the equipment operates correctly. That's kind of where we've seen the quote-unquote false alarms is caused by outside interference usually.
Does anybody else have questions? I got some more here, but I want to make sure we fill in your questions as well. Okay. This question is the wireless versus cloud. What are you guys using in your systems, and what kind of problems or what's the good and the bad that you've seen in the operations and production side of it?
As far as the wireless out option, it's a little more expensive, but it does give you the opportunity to install a system where it can be installed at a leg further away from your facility and communicate wirelessly back to your office, back to a location where somebody's going to be to see or hear this alarm that's going off. So it's giving you an avenue to have more equipment in remote locations without the extensive wiring required to get it back to a place where somebody's going to be. As far as sensor by sensor wireless, it's still too expensive to complete that. You're better off wiring an entire system remotely and then having that wirelessly communicate back to your server or your office where the personnel will be. And then as far as the cloud goes, like Brian was saying earlier, we do receive emails based on every alarm that is registered in our system, and we can utilize those to see trends. I mean, it's real nice, like if second or third shift's there and you see multiple emails come across, and you can basically tell what the guys are doing, whether you're seeing multiple rub alarms or speed sensor issues. You can see that they're either working on it or troubleshooting it at that time.
I know at like a lot of our facilities, we're very remote and we don't get real good internet source a lot of times. It's very slow and sometimes very limited. In your experience, do these systems require a pretty efficient and high-speed internet source? Is that going to be kind of a determining factor on whether you go wireless or not, depending upon what internet providers and systems that you may have in place, or how sensitive is it that way?
Not necessarily, because the local server's on site, so it's not relying on your wireless connection back to the cloud. Even if the power's out at, say, where your server's at, it's going to collect that data, and then once it receives a wireless connection again to talk to the cloud, it's going to send out an update, and you'll see that because you'll end up with 30 emails right in a row.
Okay. Any other questions that the crowd's got? Okay. In the event that your hazards monitoring system goes down, what's your procedure at that point if that system quits operating?
I know in our company, the first thing it requires is notification to the absolute top of our company. They have to allow or override any special procedures that we will do. If it's a faulty bearing probe, we don't necessarily have an issue with that. We can post somebody on site that monitors that bearing every half an hour or every 15 minutes, every hour. We could overcome that. A speed sensor, we can't operate without something there to tell us what the speed is. Again, if we wanted to use an RPM device and with a tachometer check and constantly be monitoring that would be an acceptable workaround, but we just don't go there on a speed sensor. And again, this requires lots of spare parts. This requires someone on our staff that is an expert in the system, and I can tell you he's been up all night long troubleshooting these things, getting them back up and running so that we can operate, because we're effectively shut down until the system is repaired in many cases, because we will not bypass some of those conditions. Rub alarms, again, you could visually check. If you have a bad sensor, you could physically check and watch manually that your alignment is correct, but again, we typically would not do that.
Yeah, with that, I mean, we've added it to our preventative maintenance program to check each system every time we PM that piece of equipment. So we're constantly testing the equipment. As Brian showed the picture earlier of the CMC device, that is the tester for that type of sensor. There's many different ways of testing it. There's freeze spray out there now where you can spray cold spray on it and watch the drop in temperature. You can literally take it and hold it in your hand and watch it rise. You can ohm it out. But these systems need to be tested on a regular basis and make sure that they are working properly.
I know a lot of us, when we're building new systems, it's kind of a given anymore that we do a lot of hazard monitoring. But I would say a larger percentage of it are older facilities that 20, 30, 40 years old, if not older. What kind of issues do you get into when you're retrofitting an existing older facility, putting hazard monitoring systems into it, and then kind of how do you work around those issues when you get them?
Some of the issues that we've had or that I've experienced in the past with older systems, primarily it seems like back in the day when these things first came out, the insurance companies mandated it. Nobody understood it. Nobody knew what it did. So we have to put in rub blocks. We have to put in, but they didn't put them in right. So if you actually followed the belt, move over to the casing, it's 6 inches away from where the belt would hit the casing on the head pulley where the pulley doesn't move. So it's verifying that first and foremost. Then it comes down to if you're looking at your system. For me, it's if it's functional, it does what you need it to do. Go with it. Keep it the same. If you have to expand, go with the same thing. Because when I run an elevator, the worst thing for me was having two different systems that I had to maintain and have maintenance guys know how to do two things. If it's not doing what we need it to do, then we're just going to change out the whole system. So.
You brought up a great point about in the old days it was bare minimum. So now we recognize this as a tool, and we want to maybe add more points, maybe cover more equipment. So again, a lot of times with the old systems, maybe we could only capture 12 ports, and we might need to add another board to where we can pick up a few more reading points. And I guarantee you we are adding new equipment and new capture points all the time in our systems. Our facilities want that, and we want it from a operations management team as well to start protecting as much of that equipment as we can.
The other thing we look at is, or I look at, is just not only whether or not it's inside or outside, which is the only thing that was looked at when this first came out, but how critical is it to our operation? If that goes down and we're done, I don't care if it's 100% outside leg, I want hazard monitoring on it, because I don't want the first time that I know there's a problem to be when it's completely down. So,
what's the time frame to install a system? I mean, how much downtime do you have? What's it take from start to finish to get a system installed?
It really depends on how elaborate of a system it is, and different systems take different install procedures based on the wiring and the communications. But I mean, if you were looking at just a simple one-leg install, you're looking at about a week.
but you don't have to be down the entire time. I don't shut down when people are running conduit outside. So, I mean, you can run the conduit, pull the wire, get everything up there ready to go, and then you shut down, get everything cleaned up if you have to cut holes or do whatever. So, you should be able to, within a day, I think, install most of the things. 1 day of downtime.
What do you guys keep on hand for spare parts? I know, Brian, you talked that, there's that spare parts list, and I think putting in a system like this, what kind of spare parts do you try and keep on hand so when you go down at 8 o'clock at night on a Friday night during harvest, you've got what you need?
Locally, we keep extra sensors on hand as far as the servers for each unit and communication devices. It's kind of location by location and depending on the priority of that location. We've got a lot of facilities within the same region, so we'll keep extra servers, in a triangular area, so that if a server would go down, they're the most expensive piece to the equation. So we'll keep it at a nearby location that can get it to the other location within a decent amount of time.
I can tell you on our system, I don't know the exact spare parts list, but I will tell you that in our system we have work orders that come up on a certain frequency that says, here is the list of spare parts that your facility is accountable for, and then you need to physically go out and double check that you still have these spare parts on your shelf. And that's important to us, again, when we talk about they might be keeping spare parts for that location that's an hour away or 2 hours away. So it is absolutely critical that we keep those parts on hand.
Okay. When we look at hazard monitoring, I think a lot of times we look at, okay, we get a hot bearing, we get a belt that's out of alignment, we go and we fix it. Kind of comment a little bit more on the preventive maintenance side of it. How does your hazard monitoring, how is it helping you on your preventive maintenance to maybe keep from getting those things? How do you utilize it on that end?
I mean, again, it goes to the predictive versus preventative. Predictive, you can watch the trends. If you constantly have a trouble bearing that continues to send you alarms, there's obviously something going on with that bearing, whether or not it's going out or it's just getting missed on the preventive maintenance and not getting fresh grease purged through the system. When you see those trends, you can investigate it and see what the root cause is.
Okay. Any other questions from the group? I want to make sure we get everybody taken care of. Okay, I want to help me in joining in thanking these guys. These guys didn't know this morning they were going to be doing this. Okay, I think they did a fantastic job for like no preparation. So help me thanking them for doing it.